This graphic organizer is just for you guys to have a reference for how to go in between all the graphs and the relationships between them. So you're going to be working on the skills of if you have a position time, how do you get the velocity time? If you have a velocity versus time, how do you get the acceleration versus time? And backwards, how do I go from here to here and from here to here? So we have the three graphs on here. I'm going to jump around a little bit, but let's go ahead and start with this constant slope right here on our position versus time graph. So if you have a constant slope, that means our displacement from the origin, in this case, this displacement is increasing at the same rate. And since velocity is position over time, if that change in position over time is constant, that means a positive slope means that I have a positive velocity. So if we were to actually go and calculate this value, so looking at the times here, we can create a value. So if I say that this is about 4, and I'm making up 34. I have no idea if it's 34. It could be 33, 32, I don't know. So 434, and we're going to call this guy, if this is 5, 6, I'm going to make this 7. And it's just a little bit above 80, so I'm just going to say 82 for giggles. Okay, if I were to calculate this slope right here, okay, then what's going to happen is I'm going to get this value for velocity. So doing that, we would have the change in position from 34 to 82. Do I have that? That is 34 to 82. That's 48, right? So 48. So I rose 48 meters, and I did that in 3 seconds. So that gives me a velocity of, so that gives me a velocity of 16 meters per second. So coming down here, this is 0, 5, 10, 15, and sure enough, that does look like it's just a little bit above. So this is going to be 16 meters per second. And notice, this is constant, so this is going to stay 16 meters per second for this time interval. That's not going to change. So this is a constant velocity. All right, now if we take a look at the rest of the position versus time graph, we're always curved here. So, so our velocity, when it's curved, our velocity is going to be changing. So we're going to either be increasing or decreasing in speed. And then we also need to talk about direction. Now, since we've been talking about this section here, notice my change in position from here to here. My change in position was 82 minus 34, and that is 48 meters. All right, in the positive direction. Now coming down to this graph, let's say you were given the velocity versus time graph. And I said, hey, I want you to tell me from a time of 4 seconds to 7 seconds, tell me what the change in position was during that time. That's when you're going to find the area under the curve. So we're looking for this area. So if we find the area underneath that curve, that is going to be 16 meters per second times 3 seconds would be the base. So this would be 3 seconds. And sure enough, we would get 48 meters. Now this tells me what the displacement during that time was, but I would need to know that I'm starting at 34 to know that I'm going to go from 34 to 82. So all I know is that the change in displacement here is going to be 48 meters if I'm jumping from this graph to this graph, okay? Now the last part of this section I want to address is here my velocity remains a constant 16 meters per second. And what that means is that my acceleration must be 0 because acceleration is the change in velocity over time. But my velocity is not changing. So going down to the same time frame down here, my acceleration must be 0. Okay, so all these pieces match up together. So to get the change in displacement, I find the area under the curve. To get the velocity, I find the slope of the position versus time graph. All right, so let's go to, let's jump around here. let's go to, let's put this in here. Let's put the change in velocity as 0, just as a reference. All right, so going over here, if you'll notice, I'm starting at 0 and I'm coming up here to 16, right? So this is 16 meters per second. This is 0. So my change in velocity here, my change in velocity is 16 meters per second in this section. And it's over a time of 4 seconds. Well, acceleration is change in velocity over time. So 16 divided by 4 would be 4, and if you notice down here, in the first 4 seconds, right, my acceleration is 4 meters per second squared. How did I get that? That's just the slope of my velocity versus time graph. So the slope of the velocity versus time will give me my acceleration, and we have the, and then let's talk about this. What if I started with this? Okay, so if I started with my acceleration versus time graph and I said, hey, you know what, in this first 4 seconds, this is my acceleration. I want to know what the change in velocity was during this time. If we find the area here, so the area is 4 meters per second squared times 4 seconds, that's going to be 16 meters per second. And notice, that's the change in my velocity in that time interval. Now, the additional thing I would need to know if I were going to graph the velocity versus time is I need to know what my velocity started at. So in this case, my velocity started at 0, and then I would know at 4 seconds my velocity is 16. Your velocity does not have to start at 0. If I was given this graph and I said, hey, your initial velocity was -20, then what would happen is on this graph I would start at -20, and then I would draw a slope of 16 up to 4 seconds. Okay, so moving on, I have a positive acceleration, I have a positive change in velocity, and this is what the curve looked like. Okay, now we have 2 types of curves that we're going to be looking at in terms of acceleration. We are going to look at one that's concave up, so I like to draw a smiley face for that. So notice this creates like a smiley face curve right here that's concave up. Anytime you have a concave up curve, you are going to have a constant positive acceleration, okay? Versus where we have part of the graph where it's concave down. So this is concave down. And what this tells me, without being able to even draw the acceleration graph, at this point what I know is everything in here, okay, everything in this area where I have this frowny face, the upside down smile, I know that the acceleration is going to have a negative value. All right. Now to get that, if I started with this, it's a little bit harder. I would have to get a handful of points and draw them on the velocity versus time graph and draw a straight line for this area. A couple things I do know though, looking at 15 here, if I come up to the top, right, what's happening here is I am moving away from the origin during the whole time that I'm coming up here, right? I'm moving further away because this is a position versus time graph. So my position value, the numbers are getting greater and greater and greater. In this instant though, I'm now turning around such that I'm now moving closer to the origin, okay? When that happens, when this turns around, all right, the velocity is 0. Now here it says the horizontal point, which is a 0, so implies 0 velocity. And that's because what they're doing is they are taking the tangent line slope here. Okay, so the slope of the tangent line here is 0. If I did a slope of the tangent line here, it would be a negative slope. So let's do that in orange here. So if I do this, then this would give me a negative slope. Okay, and what that tells me is that my velocity is negative. So when I come down here, all this has to be in the negative velocity area. So coming back up, my position is increasing, all right, and then I have, and then I'm stopping and I'm turning around. Now when I'm stopping here, that means my velocity is 0. Down here, I know I can plot this point. Okay, so this is v equals 0. I'm not moving right there. Now notice, even though my position is increasing, notice how I have a negative slope. That is because I'm coming to a stop. So on your velocity versus time graph, as our graph approaches the x-axis, what it means is my object is slowing down and coming to a stop. After this, what's happening is I am now speeding up, but now I'm speeding up and I'm moving in the opposite direction that I was here. Here I'm moving in the positive direction. Here I'm moving in the negative direction. So positive direction slowing down, negative direction speeding up. Not to be confused with this graph. Here I am always to the right of the origin. Everywhere on here, I'm to the right of whatever my origin is. But what's happening is I am moving away from the origin here, and now I'm moving toward the origin. So my motion, even though my position is positive, my motion is in the opposite direction, moving toward that. Therefore, that's why the velocity here is negative, because this means I'm moving. If we were going left and right, this would mean that I'm moving left. Okay? Now, this is tricky, because everyone's like, oh, well then, are we moving right here? No. Here, my velocity values are still negative. Okay? Since they're still negative, that implies that I'm still moving left. Okay? Now, what else is happening here is I'm getting closer and closer to zero. So what's happening is I'm speeding up, and then I hit my maximum speed, and then I start to slow down very quickly. Okay, so that is the part in here. All right, so let's take a look back at the graph here. All right, so here I am concave down, so I know my acceleration is a negative value in here, but here notice I switch to a smiley face. Okay, so what's happening here is now I am slowing down, right? And now in this section, even to be more careful, in this section my position is not changing. If my position is not changing, right, then my velocity is constant. However, my velocity is a constant 0. And if my velocity is a constant 0, then my acceleration is also a constant 0 value. Okay, let's see, what else can we do here, you guys? Let's talk about this negative acceleration a little bit more. Okay, so for the negative acceleration, if I look at this section, I can find the area. It looks like here that this part is a negative 2 meters per second squared. And then if I'm looking at this part, it looks like it is from, I don't know, this is 4 seconds. This is 5. This is 10. I'm going to say this is, oh yeah, I counted this as 7 seconds. So this is 7 seconds here. And this is going to be all the way over here. I'm going to call that, it looks like 23 seconds. Okay? So if I find the area is going to be 23 minus 7. That is, how much time is that? 16 seconds. So I have 16 seconds times negative 2 meters per second squared. And so I get the area as negative 32 meters per second. All right, this is what this means here. This area is how my velocity changes during that time. And what that means is at 7 seconds, I'm up here at 16, right? So 16 meters per second here. At the end of this time, at 23 seconds, I should have had a change in velocity by 32 meters per second in the opposite direction. So 16 minus 32, it means that this is negative 16 meters per second. So that is the change in my velocity during that time. All right. So that's just kind of a beginning to try and get you used to that. And I know it's a lot of information. We're going to do a lot of practice with this, so just kind of hang in there and keep a positive growth mindset.